Functions. Let's consider the following functions. fx equals 2x plus 1 and gx equals x squared plus 2. The understanding of what functions are essentially link to equations on a graph. So this might be the line of fx, where we have our x and y axes, and then we've got x squared plus 2, which might look a little something like that, and that would be gx. So instead of them equaling y in terms of y equals mx plus c for our first equation, we don't want them equaling to y because they don't equal to the same thing. So we're just calling them f of x and g of x to show that they are two different functions. Different style questions that you may get with functions, we may get something like f of 4. So what this means, our x, where x was, is now 4. Graphically speaking, what that means is we are trying to find our solution when x equals 4, so x on the x-axis where 4 is, what is that value of fx or y? So we're replacing x with 4 in our equation. So 2 times 4 plus 1, so that's 8 plus 1, which is 9. Alternatively, we may get, for example, f of x equals 12. Solve for x. And in this case, we are told that fx is 12. So fx is 12. So that's 12 equals 2x plus 1. Take 1 from both sides. That's 11 equals 2x. Divide both sides by 2. That's x equals 5.5. Next, we're going to look at an inverse function, f to the minus 1 of x. Two different methods here. I'm going to show you two different ways. Now, the first method I'm going to show you is using a number machine. This is a great method if we've got quite a basic function. So if f of x is 2x plus 1, we consider what we are doing to x. You're multiplying it by 2 and then you are adding 1. The inverse function is doing the opposite and going in backwards. So we're taking 1 away from x and then we're dividing it by 2, leaving us with x minus 1 over 2. Alternative method is the rearrange method. So what we're going to say is that y equals 2x plus 1. So instead of fx, we've just changed it to y. It doesn't have to be y, it can be any letter of your choice. And what we're doing is we're rearranging to make x a subject. So we're going to take away 1 from both sides, and then we're going to divide by 2. And what we see is where we've got our y here, y minus 1 over 2, we're just going to change that for an x, because our inverse function is in terms of x, so that is x minus 1 over 2. So you get the same answer in both cases. Next, we're going to ease ourselves into composite functions. So we're just going to rewrite our functions below. So fx equals 2x plus 1 and g of x was x squared plus 2. We're going to start with a composite function like this. So f of g2. What this means is find out what g2 is, and then you substitute that into f's function. So we start with g of 2, so again we're substituting 2 into wherever x is. So that's 2 squared, which is 4, plus 2, which is 6. So now it becomes f of 6. So that's 2 times 6 plus 1. 13 is our answer. Then we might see, okay, g of fx. So it's now a composite function in terms of in terms of x. So what we're doing here is we have fx and we are substituting it into g's function. So instead of a number going in place of x, it's a whole function. So we get 2x plus 1 is going in place of x in g's function. So that is squared plus 2. And now it's a case of expanding. When we're squaring, we want to use double brackets, and simplifying. So g of fx equals 4x squared plus 4x plus 3.